everyone, and welcome to the Ethereum Core Devs meeting number 77. My internet connection is now fixed. I didn't even have to call, they just fixed it. And so my upload's good, so there shouldn't be any stream problems. Okay, so now that we got everyone on here, let's talk about the Istanbul update that happened about a week and a day ago, or less than a week ago, I suppose. Is there any update from anybody? It looks like it went well. We had a community call that I thought went really well during it. And according to the Ethernodes website, the last time I checked, I think it was like 95% of nodes had updated. So if you were out of sync, yeah, it was 97% now of nodes have updated. So if you were out of sync before, you are now immediately in sync. Um, because you updated because you realized, oh no, I'm on the wrong fork. Oh, there's even good stuff from Mere Glacier we'll talk about in a little bit. Um, so now let's see here. What's the next thing? We got on the wrong page. Anybody else have Istanbul updates? Okay, so now we're on Mere Glacier. Um, if you click on that link, you'll see that it is in last call, and we're going to change that to final. The review ended yesterday, and no one raised any concerns that I'm able to see in the Magician's thread at least. I'm guessing they would have left it there instead of a PR.
So one concern that I think was on the magician's thread is some people felt that the 4 million blocks was like too big of a push. So there were a couple comments. Pretty sure it's either on the EAP thread or on the either on like the hard fork thread or on the actual EAPs thread. I'm not sure, but there were just like a couple people saying that like 4 million might be too far in the future. Um, and just wanted to make sure we, to get people's thoughts
Oh,
here about that. So no one seemed like super opposed to like pushing back the difficulty bomb, but it was just like the amount by which we're pushing seemed to be problematic to a couple people.
okay. Yeah, I can see why people would think that. Okay, but it sounded like there wasn't any deal breakers though, because I'm having trouble finding it. But yeah, would you say that there wasn't anything that was like super, uh, like like showstopper about any of the requests?
So I know that we did the release for the Muir Glacier last week, and
Mm-hmm.
there have been a few comments, maybe a couple, 2 or 3 comments that it's not we released too soon, and people didn't really, or 2 or 3 people said that they don't really like it that we pushed it back too far. But generally, the rationalization that they posted was that this means that we are all of a sudden delaying Ethereum 2.0. So for some reason, people kind of link this delay to Ethereum 2.0. And from my perspective, the two things are completely unrelated.
I think
Mm-hmm.
some of the yeah, those were some of the comments. I think I just posted the thread I was referencing to. I think the one concern that at least I don't know two people seem to have was like if we push the bombs so far, does it make it harder to ship stuff like the finality gadget, which will potentially reduce issuance for miners? And what's miners' incentives to like upgrade to that if there's not the bomb in place anymore? So it seems like there's at least a little bit of concerns on like the 1.0 side and or at the very least the like link between 1.0 and 2.0. Um, so yeah, I shared the thread. Like I don't want to like kind of put words in people's mouths, but that seemed to be another bit of the concerns. At the same time, it's like one or two people had those concerns, so it's not clear to me how like generalizable they are to the entire community, and yeah.
Okay, sounds good. Let's see. I think that that is fine then. I think we can go ahead and just continue to mark it final because there seems to be some misunderstanding with the implications of ETH 2.0, like Peter said.
So
Anybody opposed?
so my generally my reply to these people was, and I kind of still stand by it, that we're kind of pretty late to start debating on whether 4 million or 3.9 or however much would be more appropriate. So my suggestion is that we go ahead with whatever, so that we can just release the thing and make sure that Ethereum still functions in a month. And then if somebody
Hmm.
feels really strongly that this is a bad number, I think it's completely fine to adjust it in the next fork if somebody is really opposed to it for some reason.
Got it. Okay. I am not finding those comments anywhere, and I keep looking.
I
But
think if you search for the Reddit, the Geth 199 release, I think on Reddit.
oh, I was looking in the EIP's forum. Okay, yeah, I remember that thread. Okay, well, I don't really need to see it for it to know it's been there because y'all are talking about it. So, um, let's go ahead and move on then, and just say that we will be addressing the difficulty bomb um, at some point. I believe it'll be before the 4 million blocks hit because we already talked about that. So I think that's sufficient personally for um, dealing with the delay and adjusting it if necessary based on community feedback once that happens or once we get like after Muir Glacier. Um, and I also encourage people who do feel like it's not accurate to make another EIP that it either adjusts it, takes out the difficulty bomb, extends the difficulty bomb, whatever you want to do, so that those can be up for consideration after Muir Glacier.
And I guess, yeah, one thing I'll just add, the reason I think we should still go to final is the absolute worst case scenario seems that, if it's true that like miners will not upgrade like unless faced with the difficulty bomb, which I'm not personally convinced of, but like anyways, you take that as a given, then it seems like in the worst case what you get is something like the finality gadget won't go live until the bomb kicks off, which is like in 1.5 year or something like that. um I'm not sure how quickly the finality could go live, but it's like I doubt you'll see that in less than like 6 to 12 months. So at the absolute worst case scenario seems like you add maybe another like 6-ish months before you can deploy the finality gadget on each one. um,
Yeah, but I don't think
I see.
that's realistic either, because so I think this whole miners will not upgrade. This kind of originates from the Bitcoin world, which is a fairly stable protocol. So people don't people expect that to not change at all, and you require quite a lot of force to change it. But in the case of Ethereum, people are more accustomed to our regular updates. So even now we have two hard forks lined up. We have the crypto stuff that we can talk about it after, I think, afterwards, after this one. We have the ETH1X research, which will, if we go down that path, it will require probably multiple hard forks. So it's not like we're freezing Ethereum one as it is now and calling it a day.
yeah, I agree with that, and I think the worst case scenario of like even if that were untrue is not that catastrophic. So I I think it's less catastrophic than like taking another 3 months to figure out what's the right amount by which to change the difficulty bomb.
Okay. Anybody else have comments, opposition, anything? Okay. Next up, we have testing updates. Um, oh, actually, one more Mere Glacier thing. Um, so it activates on the right now. When is it slated for? It's slated for New Year's Eve.
Uh, yes. Wait. So when I saw that number, I also freaked out. But then I realized that there will be a difficulty increase in a couple of days. That should add about 2 seconds to every
Oh.
block.
Oh, great.
So,
Okay.
so as far as so it was just a rough idea. So somebody please double check it. But if if what we think is true, then that should bump delay the whole thing by maybe about 4 days. So
Okay.
it should definitely not happen on New Year's Eve. But please double check.
Okay. Sounds good. Um, so in let's see, 2 weeks is the 27th. I'll just go ahead and say I think we should have a meeting in 2 weeks. It can be very, very light, but just talk about Muir Glacier. Um, and probably recommend that people who want to bring their EIPs maybe should wait for a different meeting since it'll probably be very lightly attended. Um, is my thinking because it's like the week of Christmas and other holidays are kind of around that time. Like there's about to be New Year's Eve and New Year's, so yeah. But I still think we should have the meeting in 2 weeks. Anybody else have any comments on that?
Yeah, I think a light meeting makes sense. And we can put it in the agenda that like it's just to discuss Muir Glacier.
Or maybe we might not even need a meeting. Maybe we can just like decide if we want one in like a week or something. Cause yeah, thinking about it, like if we don't need one, why do it? I guess.
Well, then probably
Hmm.
decided 2 days before the deadline. Just because a week before maybe the block times aren't that precise, but maybe 2 days before that it should be uh, pretty clear on what day the
Got
whole
it.
thing lands on.
So instead of having one in 2 weeks, we could have one on an off day, right before Muir
No,
Glacier.
no, I meant 2 weeks is fine, but decide 2 days before 2 weeks whether you want to hold it or not.
Ah,
Oh, that's
got
Christmas
it.
Eve. So decide on Christmas Eve.
Okay. We'll talk about it more on Getter. I guess we don't need to like truly decide it in this call as long as we get to it in the next few days so people can kind of plan if they want. Um, what's next? Testing updates. Anybody have testing updates?
Not me.
Okay, we can skip that one then. Dimitri isn't here, who usually has testing updates. Now we're at the eligibility for inclusion EFI EIP review. The first one is going to be EIP 1559. That one is. Let me find it in the eligible for inclusion
So it's
meta.
the fee market change for ETH 1.0. And
Got it. And
yeah,
yeah, go ahead.
yeah, so I was gonna say, I wonder if there's anyone here who is sufficiently knowledgeable about it to answer questions.
Yep. Hi. It's This is Rick and Ian, the dev who wrote the patches, is here as well. So
Awesome. Go ahead and speak on it if you'd like.
yeah, I mean, just a friendly reminder of what it basic the purpose of it, the high level purpose, and how it achieves that high level purpose. The high level point, it's an EIP submitted by Vitalik. The point is to add stability um, to the gas ether price or the ether gas price, and also it has some other useful side effects in terms of you know removing zero fee transactions. And the way it does this is basically we add a base fee. We bring the gas pricing under consensus, um, and uh, and then the each transaction, instead of having a single component in terms of the fee that goes to the miners, you now have two components. You have some of the gas is burned, and some of the gas goes to the miners. Um, and that's basically it. It's actually a set of it's a phased. So Vitalik wrote the skinny 1559, which is not what we implemented. We implemented what was in the implementation study, um, which is two phases basically, because as we can imagine, changing how transactions work. Oh, and another major benefit is it really simplifies. You no longer need Ether gas station. It really simplifies the user experience. It's much easier to um, figure out what your gas fee is going to be in advance. Um, and because it changes how transactions work, um, you can't just flip a switch and expect all of the downstream tooling to have changed overnight. That would be, that to me, that was a much greater risk. And so we've made it two phases so that there's a period of time where both transaction types are valid, which adds some complexity. But I think it's necessary to actually get adoption without breaking everything. Were there any questions?
Yes, I have a couple of them. Actually, two questions. So first of all, it sounded a bit like you're talking about the EAP as one thing and your implementation as a different thing, and I'm kind of wondering what to discuss today. Discuss the EAP or your alternate version of the EAP?
Yeah, so it's the implementation. We haven't. It's a pretty big change, and the EAP was a little, in my opinion, a little underspecified. We had hoped to have a EIP that referenced our implementation. Well, let me actually, that's inaccurate. What I had hoped to have happen was that we'd actually do some modeling and simulations to sort of prove that this isn't going to blow everything up. But we couldn't get funding for that. So what we got funding for was the implementation. So we wrote an implementation. And in that process, there were changes that need to be made. And the EIP is forthcoming, but we thought it wasn't. But those are separate tracks. Those are two different people working on those things, and so the implementation was the priority, and it also coincidentally, frankly, happened to be done first.
Okay, so it sounds to me then that at this point it's really a bit too early to make some kind of call about inclusion or not. But I mean, since you have an implementation but not really an EAP to discuss. But I do have some general, one general question about 1559. So it has this premium, a base fee and a premium, and I don't really understand what prevents all the miners from basically colluding and setting the base fee to 0 and still only accepting transactions which have highest premium and falling back basically to the same situation we have today.
Yeah, so I think before I answer that question, yeah, I completely understand what you're saying about the EIP and the review. I in my discussions with people, to be frank, it didn't seem as though it seemed as though this was the shortest path to having a discussion, frankly. Since no one responded to any of my comments or anything else that wasn't, and I mean, when I say no one responded, I mean very few people responded, and it didn't seem to. I was having a difficult time getting.
Yeah, I
people.
mean, I think it's fine. It's fine that we discussed it today. It just meant that we probably won't be able to like make a decision to.
Oh yeah, no, I don't. I don't
it's
expect.
Perfect to have a discussion about it.
Okay. I don't expect there to be a decision made today. So thank you. Yeah. So there's an averaging of the base fee over a large number of blocks. And so the idea is that the miners would need to kind of have an overwhelming amount of the transaction volume for a long period of time to adjust the price. They basically need to be the majority of demand. So it's kind of a weird.
But does the base fee follow the premium, or what does the base fee follow?
So the base fee targets a half full block. So as the gas price, so like we set an initial value that in the original EIP, the talc just sort of took a snapshot of time, but it's the gas price at the time that it's deployed. And so basically the idea is that that price, that initial price is set, and then it can only vary so much per block, and the target price is determined by taking some average number of blocks. And these are exactly the sort of questions where I thought they were very difficult to answer. And this attack that you pointed out, we sort of have this sketch solution, but I felt like given the importance of the change, we needed a lot more engagement to actually answer that question.
So interesting question that I have is, so from as I see it, this whole so essentially base fee targeting half, essentially, if I get it correctly, the idea would be that the gas tries to keep blocks half full, and if blocks are getting fuller, then the gas prices go up. Now, the question is, how does this relate to the dynamic block sizes? Because sure, on Ethereum mainnet, we kind of have it fixed at 10 million currently, but in theory, it should have been dynamic. So if we add this, how will these two values interplay? Because as the blocks are getting fuller, the miners would in theory push the block size up, which would make transactions cheaper. And your proposal is doing exactly the opposite.
Yeah, I mean,
so
that's a
that if I
sorry, continue.
I just wanted to add that let's suppose that if we were to remove the limit on mainnet, this artificial 10 million gas cap, then what would happen?
Oh, Rick, you're still on mute.
Yeah, I'm thinking about that. I don't think so dynamic. Well, but how do we decide what the criteria is for changing it?
Changing what?
The 10 million gas cap. What in your suggestion? How has that changed?
Well, the 10 million gas cap currently, that's an arbitrary limit set by miners, but based on the Ethereum protocol, it should be pushed upward as if blocks are full.
Oh, I'm sorry. Yeah, that's under consensus. So
yeah,
I think it would stay effectively. You're right. It doesn't. We don't change that. We just change the price.
Yeah, but what I'm saying is that the price. So essentially, the problem is that in theory, what the Ethereum protocol specs is that if blocks are getting full, the original spec was that the gas limit should be raised. Now you're saying that the price should be raised, but I think it should be important to touch on what happens. For example, what happens on a network where we don't have this limit. For example, on Rinkaby, currently we configured it that the blocks are 10 million in size, but they are allowed to go up until 15 million if there's high network traffic. Now, in this case, the trigger for pushing the block limit up would be that the blocks are full, but at the same time, in your EIP, this would also trigger transactions to be so expensive that the blocks won't be pushed up. So I just want to make sure that we're not accidentally murdering an existing mechanism with this one.
Well, I appreciate that comment. I think that it would be, I mean, all joking aside, I think it would be intentional. So, yeah, I mean, I think that I didn't realize Rinkaby had that dynamic, pricing. Also, or that dynamic sizing.
I mean, if you're creating an EIP that deliberately murders it, that's fine from my perspective. What I'm actually trying to get to is not to just ignore it, not to forget about this aspect. So I'm completely fine with proposing an EIP that clearly states that this will be murdered.
Yeah, thanks for the feedback. I mean, that's exactly the sort of feedback that I've been having a difficult time receiving. So, thanks.
I have another question. So right now there's a cap. We know that even when the blocks are full, we won't go over 8 million, 10 million, or whatever it is. But here in this proposal, it looks like, yeah, we'll target 8 or 10 million, but actually the hard cap is at 3 times that amount. So it might be suddenly 24 million. A 24 million gas block would be valid. Am I reading it right?
Yeah, it targets much lower than, right, exactly. So during normal, that's sort of like a congestion ceiling, headroom for congestion.
And
yeah,
that looks, it feels a bit almost reckless. But I mean, there are some security implications about not, well, having the roof 3 times higher than where we want to be. And I think we maybe want to be a bit more conservative, actually.
Essentially, Martin is saying that it would be a really nasty denial of service vector if somebody figures out a way to attack Ethereum, and all of a sudden you have 3 times as much leeway.
Yeah, I think, again, I completely agree with that. And I think that yeah, if someone were able to sustain that, I mean, as far as I'm concerned, I sort of volunteered to shepherd this EIP through. I think these, of course, are, I mean, you guys know this stuff better than anyone else, basically. I think these are really great questions. And these are exactly the types of questions that I was trying to surface prior to writing any code. But this seemed to be what most of the people who were giving me feedback in the community wanted. They wanted to see the implementation before we answered these sorts of questions. So, yeah. So
Yeah, that sounds like the right way to go. I think it's good that you did that because then people can look at the code and then dissect it a little further than just a lot of hypotheticals, I guess people would say.
Yeah. I mean, it's an interesting process I mean, it's not how I've worked in my other professional capacities, but yeah. Okay. So yeah, I think, I appreciate the feedback, and we'll definitely keep that in mind.
Yeah, and taking this to like the Ethereum Magicians thread is going to be very helpful, I think, to Rick and the rest of his team. So if anyone here has further stuff after looking deeper into the implementation, I think that would be important. And then even more important than that, in my opinion, would be an update to the EIP itself, even if it's not push through the EIP process, having a PR that has the changes, Rick, that you and your team have implemented that might be different than the PR, which I think was last updated in April. That would be pretty important so that people can comment on the latest one and not have to refer to a previous specification that's not updated.
Yeah, we'll take care of that. We'll take care of that. Hopefully this week.
Perfect. Yeah, and I mean, it's the holidays, so it's not like a huge rush or anything.
Yep.
Before we kind of deflect into a different topic, I just wanted to emphasize it a bit more because I kind of have a feeling that it's not really taken as seriously as Martin intended. So currently, the 10 million gas limit that the Ethereum network is running on, well, the reason why it was originally capped at 8 million because that was considered the only sane limit so that this IO doesn't murder the network. And yes, we did some optimizations, and now people pushed up the gas limit to 10 million. But essentially, we really don't want to get into a position where all of a sudden, let's suppose that we can handle, I'm just saying a random number, 15 million, and after 15 million, things starting to get screwy. Now, if you all of a sudden allow people to expend 24 million, then it's going to be really, really bad. That's why I'm saying that if we kind of currently feel that the Ethereum network's capacity is at 8 or at 10 million, we should really have some very, very hard caps in place so that you cannot really overblow the resource usage. So honestly, I would, instead of instead of a 3x multiplier, maybe a 1.5 would be a lot more saner starting point.
Yeah, and I don't. Frankly, I mean, we sort of went with the parameters that Vitalik gave us, where he gave us them. So I don't know why he picked such a large value. And I don't, and so I'll definitely keep that in mind.
Well, so the 3x is not a horribly bad idea if you look at the average network usage. So currently, Geth can process blocks in I don't know, honestly, I haven't checked, but maybe around 150 milliseconds. So if you were to 3x that, that would mean maybe half a second. So that's not that bad. But the thing is that this is the whatever people throw at it when they are using Ethereum. It's not the worst case possible attack scenario. And we need to keep the limits in control for that scenario.
Yes. So when he did look at the distribution, I do remember from the EIP that it was based on an assumption of block distribution that I thought didn't really fit reality. And I think that you're touching on that point from a different perspective. And I agree that there needs to be. I frankly don't. I mean, we're here having this discussion because I don't know how to demonstrate or simulate or make any sort of formal assertion about what that value should be. So I mean, I'm definitely open to suggestions. My intuition is that you would have to run a fairly robust simulation um, to answer that question.
Okay. Was there anyone else with comments or anything to add at the end, Rick? It's best to reach out to you on Ethereum Magicians, I'm guessing. Was there any other um, outlets that you wanted to bring up as far as how to address this or contribute?
Yeah, if we can just keep the conversation in ETH Magicians, that would be great. I don't know what the convention is around PRs. I mean, the code size is relatively small. Obviously, the impact is very large. So I don't. I mean, when I say PRs, I mean I don't know if we want to have like a named branch on our fork that people want to interact with. If they do, just at me in the getter and I'll I mean I think the link is already provided, but if people have a hard time finding it or whatever, uh, we can sort of engage in the on GitHub and ETH Magicians.
Awesome. And just to extend my support on this, you can reach out on Telegram if you do have any questions about the EIP process or the um, process of getting this through for more potentially rapid discussion. I'm happy to talk to you about that.
All right, great, thank you.
All right. The next one that's eligible for inclusion, EIP review, is 1962. That one is.
Uh,
Why am I not finding it?
I'm here, guys, for this discussion.
Oh, perfect. Go
Alex.
ahead.
Yeah. So, well, first of all, I'm sorry for distraction for the last few months because we were well, I was busy with academic side, publishing the paper which we had to finish. Otherwise, on the implementation, there is only one major roadblock right now, and this is how to measure the gas cost for uh, precompile call for one particular curve family, uh, where my initial ideas on how I would do it, I actually failed. So I was kind of simulating the calls with a lot of parameters, around 1 billion, uh, just drawn uniformly from available parameter space. And then I was trying to do the kind of multi-parameter fitting. Unfortunately, dependency on some of the values was a little bit weak, so I couldn't factor them out and get a final formula. So I will now have to do it another way by first dissecting the function call into three parts, which are independent and which should have quite trivial um, kind of a priori parameter dependencies. And then I will have to just combine the three formulas. But unfortunately, I have to do all this measurement once again. After this, there are no technical problems in terms of kind of all the same stuff will be ported from the Rust to C++ implementation, which was done before, and the same ways it will be run of another fuzzy testing to check the correspondences between those two. So it's plainly just sit, write the code, do the work, and borrow some computation time from cloud provider.
So this is the EIP about EC arithmetic and pairings with runtime definitions over such families as
Yes.
BLS 12, BN, and MMT 4/6 is what the EIP says, right?
Yeah, and the curve families for which I have this problem is this MNT 6 type of curves. Fortunately, those
Okay.
are not too pleasant to work with.
Yeah, and I'm looking at the Fellowship of Ethereum Magicians. It looks like no one's commented since August. And the last time that someone has, it was July that Dano talked about getting some test cases. And so the roadblock is still that curve in order for you to generate test cases. Am I reading that correctly from the Magician's form?
Well, in the main repository where there is a Rust code, there are few test vectors which were dumped just to for known curves, which can be pulled from either various papers or just various kind of standard repositories with curve descriptions. Uh, for those, I just dumped the kind of binary encoded blobs, which are in the right form of the input, and then the precompile should return some answer, either yes, either boolean or just another series of bytes. Those will be available, uh, but right now there are only two kind of implementation and like almost full scale implementations, which are both done by us, one in Rust, another one in C++. And to test correspondence between them, to check all this, well, to check for consensus between two different implementations. We do the fuzzy testing, which basically first fuzzes the contract itself, and then also compares the output result. So for this, I can definitely make a huge set of test vectors, but final testing should still be done by just a lot of brute forcing and fuzzing for difference between outputs for the same set of inputs.
I'm wondering about the so the EAP links to a Matter Labs repository. Is that is that the master implementation? Is that correct?
Yeah, well, there are two. One is in Rust, which is my kind of main working repository and which I use for right now for gas schedule estimation. Another one is also in MetaLabs GitHub, and this is a C++ implementation, which also is named E 1962-CPP, I think. I know that people from EY, Ernst and Young, were interested in trying to make an alternative one. I talked to them, I think, 3 weeks ago. Um, but I mean, they looked at the specs at the explicit formulas, which were also um, that were also published quite a long ago at the GitHub. but I didn't hear anything from them yet. So I would consider that for the first two implementations, it will be those two, and they will be tested this way for correspondence between each other. Um, Personally, I would suggest that it should because those two implementations are both done by Matter Labs, and it's not kind of very much independent. I would argue that it's much easier to use just one because it lifts a lot of questions for consensus results. Uh, but it's kind of still the difference between those two will be very small. So it's still kind of easier to use just one, even while they will be tested for difference in output.
Right, but and the core problem here being that this is extremely complex stuff. This is basically an EVM for complex cryptography.
Um,
So I totally agree that it would be a lot simpler to just have one reference implementation, because then you wouldn't actually need to specify everything, and then you'd have just consensus by reference implementation. And it feels kind of dangerous and to do that,
um,
in my opinion.
no, well, my argument is not that I don't want to have separate implementations. I would want to have separate implementations, but right now those two implementations that will be available and in any form production ready, uh, they will be both done by us and will be both done by kind of the same set of public documents and specs, uh, and
Right. I
kind of
mean,
follow the
even
design decisions. So the difference between them is just so small, most likely. I mean, there's also different languages, but the difference which one would expect will be small. So I, unless there will be a next one and next one, uh, I mean, for this period of time until there is no next one and very much independent one, it's kind of less risk to use one, which will not crash, but will just anyway give consistent results. Uh, then try to use two, which are very much similar.
so the Matter Labs documentation also contains an ABI interface description, and that's
Uh,
part of the consensus, right?
well, I mean, the binary interface is one of the simplest part, uh, and the binary interface is implemented in both C++ and Rust. And I mean, this is just the way how you slice the bytes and how you interpret each of those. After this, there are arithmetic operations. Uh, and I mean, the ABI part, it's first of all, it's arbitrary and it's kind of can be changed a little bit, but for now it looks reasonable. And for the part where the discrepancy may come, it's much larger chance that it may come from arithmetics, even while the formulas everywhere are explicit. And those are present in a separate document with all the explicit formulas. Uh, it may be that just during the implementation, one check or another one just went missing. And there is much larger chance that it happened not in ABI, but in arithmetics, just by the number of lines of code which are responsible for each of those.
Oh yeah, sure. Um, yeah, I mean, but it's just kind of a sign of how big this EAP is. If there's a full ABI implementation, which isn't even mentioned in the core EAP.
Yeah, because ABI design was kind of flexible and the time we started to make it. I can kind of make it freeze and solid, uh, but I don't think it would help anyone. I mean, having an ABI implementation without the rest is it's not something which you would want to have for independent implementation. But I mean, for from the experience of previous run of fuzzy testing between two implementations, we have found a set of discrepancies, uh, which were kind of checks if some stuff was empty or not, for example. But we didn't find any discrepancy in ABI parsing code between our Rust and C++ implementations, for example. So it's just from empirical experience, there is much smaller chance to get an error there.
So my concern is, why do we even need an ABI? We got 28 separate functions with a lot of different ways that you need to pack the parameters, with a lot of different ways that we need to gauge the gas. Wouldn't it be conceptually simpler just to have each one of these pairs of function and curves have their own individual call, and we could easily isolate the testing cases that way?
It's, I mean, this is not a problem. And yes, we can have the 20 separate formal precompiles for each of those. Kind of my point there is that the way how you pack the parameters in each of those is just so similar that basically there are only, I think, 2 bytes in ABI right now which specify each of those calls. And everything else is kind of uniformal way how you encode, for example, an integer using the byte, the big endian representation. So, I mean, 2 bytes address which call you do. And the rest is just uses the same set of parser functions to slice this bytes and interpret them in some way. So there is no independency between, I mean, even if you separate it into 20 separate function calls, which is still fine, they will still have very similar looking way how you would call them. So they will have their own kind of binary interface. And when maybe I did use the ABI a little bit wrong, this is just the way how you pack the parameters mostly. And you use 2 bytes to specify which call you want to make.
Why do we even need those 2 bytes? I mean, if you also, what's the issue with the gas calculation? There's different gas calculations for each curve, and then to calculate this in the implementation, we're gonna have to put a giant switch statement, which I think would be easier just to say that this curve has its own set of functions with this gas calculation, rather than this curve, you do this giant 4-way switch depending upon which curve you're on, and then you go down these complex things.
I mean, just from the way how I mean, just from any perspective, how the implementation would be done, the difference between those is just literally one switch statement, which is much simpler part than the rest of it. I mean, for every function, we'll use what the entity which is a finite field, and no matter which of those calls you will use, you will have to first specify the parameter of this finite field, and then such parsing will be done inside of the call to any of those 20 functions anyway. So there is no good independency between them. That's why when I working on it right now, I just didn't separate them, because there is no good separation between them. Kind of anything, kind of the switch statement at the beginning, yes, it tells you which functions you call. But after this, all of those 20 functions, they just use the same set of primitives to do their work. So they're not that much independent. And the same is for gas scheduling. I mean, it still will be the same way. You just choose which function you call to do the estimations.
But from a design perspective, if the first thing you do is jump into a switch, maybe that's an indication that you just factor those out as independent functions. Yes, there's a lot of reuse behind the scenes, but why do we need to hide it behind a switch?
Yeah, so this is what I wanted to also highlight, that it's perfectly fine to have one single function implementation-wise within the EVM that just does a big, huge switch and calculates everything the way that's cleanest. The reason people are suggesting the 24 or however many precompiles is because the EVM is kind of all the other operations are structured in one way. And if we were to have 24 precompiles, then yes, maybe behind the scenes, those 24 precompiles would just call the exact same single function, but it would avoid introducing an extra encoding idea or concept into the EVM code itself. So currently you can just say that you want a BN256 multiplication, call this precompile, these are the parameters, done. Whereas here, you would also all of a sudden also have to specify that not only do I want to call this precompile, but I want to call something within this precompile. And the question is that, is there a particularly good reason to add this extra complexity in the EVM level. Because yeah, of course, we can make it generic and make a single big switch statement within the EVM implementation. But at the EVM core level, is there a reason to have this extra complexity?
First of all, I should note that such switch statement would anyway most likely happen not at the level of EVM, but inside of the implementation, because, well, at least how it's done right now, I mean, the precompile implementation just takes a set of bytes uh, as input and internally parses it and validates it. So most likely, I was expecting that this will be the way how the data is passed from the EVM to the precompile, but this is very minor issue. The reason why I didn't want to put it initially is that, just as a solid example, in any of those calls, even if there will be 20 of those, the first parameter will always be the same. And this parameter will specify the modulus of the finite field over which you will want to work and define a curve. So even if there are 20 of those independently, you will still have to specify the parameters which are very similar for each of those calls. And this is not a huge switch statement anymore, those are independent calls. That's why I
Oh, yeah.
decided that it's kind of backwards the same way. If you have a lot of similarity in the way how you call each of those, then most likely you don't want to separate them from just logical perspective.
But
I don't have any argument that we should do one way or another strictly. If you want 20 separate function calls, I'm perfectly fine with this. I just described why I didn't put it initially.
so for me, having an extra ABI abstraction layer just to have one single modulus. I mean, I don't care if 20 function calls will have the same first parameter and you have to set it. So what I'm trying to vote against is adding extra ABI complexity just to hide something a bit further down the stack.
Okay, I mean, if this is a kind of decision, I will separate this function it as a required number of subcalls. It's not a problem from any perspective. It's just this decision was never kind of reached to the final point, and I has always said that I'm fine with any of those. And if there is some kind of if there is a consensus that we should make it 15 separate calls, then I will make it 15 separate calls. It's not a problem.
I think it would, I mean, from another perspective, I think it would be good to actually, I have a hard time to make out what are the exact operations that are supported. And then I go to the implementation and there's like, it's very hard. I mean, it's very hard to figure out. So what exactly, would it be 5 different or 20 different or 50 different methods? I mean, what exactly are the operations? I think the EAP is kind of vague on that.
Yeah, well,
it's just me not being able to read math notation.
Well,
like there are things
most
like
likely
proposed formulas and multi-exponentiation formula is different due to the use of specialized algorithm. What does that mean?
There are a few documents which describe it, but if put in short, maybe I should just re-update it once again because, but okay, I will handle it to have the better description. In short, what the precompile does at the high level, it allows you to do right now 7 different operations. First of all, there are operations which are arithmetics on elliptic curve defined over the prime field. And there are 3 kind of operations which you can do there. It's an addition of points, a multiplication of points by scalar, and multi-exponentiation, which is just very efficient way how you can save on consecutive calls of multiplications and additions of intermediate results. Those are 3 functions. Then there is a set of functions which allows to do the same 3 principal operations, addition, multiplication, and multi-exponentiation, but not over the curve which is defined over the prime field, but over the curve which is defined over the extension of the prime field. And this is usually in most of the literature is used as a labeled as a G2 subgroup. So those are three more operations. And the final operation is a pairing operation, which is supported only for specific families of curves, for which four are labeled. So if I explicitly separate all them, I will get to the number which is roughly 12, 11 independent calls.
Can I raise two different arguments? Not with the design, just in general. I think it's kind of premature to argue about ABI encoding and how any of these operations should be laid out before there are actual example codes using this precompile. Because eventually, what should be also part of the decision is the cost contracts have to incur while interacting with these precompiles, and second, the DevX experience had to actually interact with these precompiles. So I guess from a language perspective, having the current ABI encoding or having individual precompiles are both kind of bad because it requires specific implementation in each language. Or if there's no language support, then it would be some kind of an inline assembly. Maybe another option would be just to follow the standard ABI encoding. And by that, it would just look like a contract. The precompile would look like a contract and calling a specific function, and it would be clear, what the function encoding is. Now, probably the arguments against using the standard ABI encoding would include that it may be just too big, and therefore, if we actually examine how the precompile would be used. So I guess in the pairing case, it would be fine, but for doing repetitive additions, it would be just too big of an overhead. And the other argument I think people will say regarding the ABI encoding that it may be just ambiguous, but I think that can be argued.
I think I can kind of shortly answer both. I never thought about using the standard encoding. It may be an option, I just didn't meter this. And still, the cost of parsing is negligible compared to everything else. But I didn't estimate the cost of actually kind of forming the array of data in memory and doing this call. This part I didn't estimate, so I don't have a solid answer for this. For developer experience, I will link this to the Gitter just to have it kind of stated somewhere. There is an example of how one would call the precompile with the current ABI at least. And yes, this is kind of setting the parameters into a huge memory, huge chunk of memory. But this is how you do it right now anyway to call bn precompile.
On the example, I actually meant the real life example contract where this would actually be beneficial, which is not just like calling a single function on the precompile, but rather I would assume in any case you would call it a bunch of times, different functions on the precompile. So having a complete real life example would I think be necessary to actually reach a correct decision on the design.
Okay, I got your example. Yeah, I think I can kind of quickly write the equivalent of the current snark verification kind of routine, but for how it would work with this precompile. I think this would be a good example. So there is a large reuse of the parameters in principle, which is possible to push the efficiency to the limit most likely developers will want, and such optimization needs to be done only once. But yeah, it's not a problem to make one real life example.
Great. Just one more comment regarding the cost you mentioned. I think there are two important costs, both from the developer/EVM side. So the one, the cost of preparing the message for a precompile, because we want to keep that cost low. And second, the actual cost of the call, the data sent through the call. I think that the cost on the precompile side, decoding any of these, is negligible because we're creating the precompile in the first place because we think it's cheaper to do calculations on the client as opposed to on EVM. So we want to keep the cost for the contracts the lowest possible.
Yeah, well, for this part, there will, for example, if one would want to call this precompile to do the same set of operations over the BN curve, obviously there will be some overhead in terms of message being prepared in memory because one would have to specify more parameters. But after this, and the part which I measure for gas cost right now is the second part, which involves parsing, which is negligible, and then actually kind of also arithmetic, which is required. Uh, Mostly because I don't have the way to affect how expensive is the cost of memory chunk in AVM in EVM. But still, even for simplest operations right now, the cost of my very rough calculations of the cost of forming the memory chunk is at maximum 15% for a simplest call. Than the chunk, than the actual work of the precompile in terms of arithmetic, and this ratio will go substantially down for calls for precompile, which will involve more arithmetic operations.
Uh, just to give an example, for I think so what Exik was referring to is that, for example, you are saying that your current ABI encoding, you have 2 bytes that switch on various internal things, and there it could actually happen that just constructing in memory that 2 bytes in the EVM will be a lot more expensive than just to have the precompile and just to call it into it, or maybe instead of using 2 bytes, just using 256-bit integers. So these byte shifting operations are kind of expensive in the EVM, and it can be surprising to. So actually what I'm getting at is that if you pick an encoding that is as tight as possible, that might actually cost more than picking a looser one.
Yeah, well, this part I didn't estimate, and well, the reason for having the custom API is actually can a little bit simplifying my own work, because the way how the one scalar is encoded, and well, also parameters there are just basically large unsigned integers. Is there is 1 byte which tells how many bytes after it encodes this number, and then there is a sequence of bytes which is interpreted as a Big-endian encoding, and with another limitations that the top byte should be meaningful, so it's not 0. And this was a kind of very simple set of checks which I would need to do, and this will allow also me to quickly estimate over how large numbers I will have to do my arithmetic, which is also beneficial to do the quick gas schedule checks without actually parsing the full set of bytes and then checking again how many bits I actually have there if I have the redundant encoding by using for example, fixed chunks by 32 bytes. This was a reason, well, this was kind of another reason to do the custom API. So that's why I didn't even evaluate it. Maybe it's actually easier to do it with a standard API. For this, I don't have an answer. It's just another piece of work.
Well, I guess we could always just check and see. Maybe Axie could. So if we have an actual contract, a real use case, then maybe it will probably be a lot easier to just check that. Okay, if we were to encode it with your ABI or with X6 ABI or just a dumb binary encoding, which would be more preferable. And probably it's something we can try out if we have actually live code to play with.
Yeah, probably my main message is that we definitely should have actual EVM implementations of contracts using the precompile or any other precompile which is proposed, because otherwise we're going to end up with a situation like we did with Blake 2, where the design had no input from how you would actually use it from within the EVM, and it ended up being suboptimal in some cases. And I think that applies even more to this precompile because it's a lot more complex. So yeah, my advice is that we should have actual examples probably written in Solidity and maybe also some in using inline assembly. And that should be one of the main drivers for the design of the ABI or how to interact with the precompiles.
Yeah, well, there is an example of such code already, and I will just link it to the Gitter so it doesn't get lost.
All right. There is an EMV or there is an EVMC binding that was posted in the chat by Axic. So if anyone's interested in that, you can check out the Zoom chat. Was there any other comments on this? Otherwise, this was a great discussion, and we can take everything back to the magicians for this.
Yeah, so I have my kind of last comment is that based on the specification, I don't think it's possible to write a consensus agreeing second implementation. I think it's only possible to do that by adapting existing code, and I think that's a problem.
Well, I don't say that the specification quality is kind of the top one, but and it will be still appended. But right now, specification maybe it's just in two separate places. Now I will check it again. There are two documents. One is about basically the ABI and the verification of the input parameters, and another one about the
I've looked.
explicit formulas which should be used to get the same explicit result.
Right, but they only define the happy paths. They don't define the actual non-happy paths. There are quite a few.
They do define exceptions, and especially the arithmetic one, it defines the exception. But luckily for us, by how you can implement this arithmetic if you use these formulas explicitly, there are only two exceptions in arithmetic. So most of the exceptions which will kind of tell that precompile didn't output any data. There are only two exceptions which happen in the arithmetic. So it's just propagated and the precompile call just returns an error. And there is much larger set in the ABI, which is just verification that all the parameters were encoded correctly. And except of this, if you just use the formulas and you just do the math and just write this, at the end of the day, you will just get the same result. Just because this is how the arithmetic works for us. If we did all the checks before.
But wait, so for example, you can have, at least for a lot of crypto curves, you can have invalid parameters. For example, I don't know, division by zero, just a stupid example. And the thing is that this needs to error out the exact same way on all implementations.
Yes, you're correct, and this is actually the one main underlying edge case in arithmetic. This edge case is basically telling us that you don't have the inverse of the element, which is actually the same as you having kind of division by zero. In this case, if you encounter it anywhere in your code, you just propagate all the way up and say that, well, my code just didn't produce any output, and this is an error. If nothing like this happens, then at the end of the day, you will get the same output in terms of it will be meaningless. Yes, it will be meaningless for any practical perspective, but it will be the same set of bytes.
Yeah, so but this is like an interesting question because, for example, in the Go implementation of of the various crypto curves, various precompiles, if you input junk, it will actually not, so it will just throw the whole thing out. For example, that this point is not on the curve, bye-bye. So it won't just start computing junk and returning you the computation results. It will actually refuse to compute it because it just does some pre-checks. And for
Yes.
example,
Okay. Okay. Let me kind of clarify this. This is part of the checks which I call for checking the input parameters. And when you actually doing a like checking that something is on the curve is input check in what I have mentioned before. And there are a few of those, but the list is finite and not very large. And when you go into just formulas and formulas and formulas, there is only one edge case. And after you did all the checks, if they passed on the same input data, then after all the formulas, you will get the same answer. So there are checks for inputs, yes, and those are, well, the same as you just mentioned, largely, and few additional ones. But yeah, if you get into one of those checks, you basically get an answer. There is no result from precompile, so just an error on a large scale. But if you didn't hit out any of those, you will get an answer which is always the same if you just use the same formulas.
Mhm.
Okay, was there anything else?
No.
All right. Thanks for the discussion. Again, we'll just take this to Ethereum Magicians and continue working on this. Thanks for taking your time to be on the call, Alex.
Well, sure.
Um,
I mean, I apologize for delay with all this stuff, but I mean,
oh,
I,
it's
I
okay.
always I always had an intention to make this work and finish this, so I will do it anyway.
I mean, it's
Good.
not as if we had time before this anyway.
Yeah, with all the hard fork stuff and other things. Um, oh, I want to go back to Mere Glacier just real quick because I realized I didn't actually check with each client to see if they have a compatible version. The Ethereum cat herders want to release a blog post, and so does blog.ethereum.org with a link to all the clients that have Mere Glacier. So let's just go through each client that's on the call and see where everybody's at. We know Geth has a client that's Mere Glacier compatible. Is there any other information we need to know about that, or do we just go to the latest version?
No, pretty much the latest version is the only one that's compatible.
Can
Actually,
we
the
Okay.
just make sure to state the numbers on the call? So if people listening, like, yeah, because if they listen a week from now or whatever.
so I think it's 199.
I think it is too.
Confirmed.
All right, confirmed. Great. Um, let's say Aleth. Oh, Paul can't. Paul doesn't have microphone. That's right. I'll just check Aleth manually then, unless someone else can speak to it. All right. Nethermind.
Yeah, it's already in the latest version, 1.2.6.
Okay.
But
Great.
sorry, Hudson, I'm going to interrupt you. Just to confirm, these versions also have the Robston thing configured, right? I
Yes,
know.
Robson block number and all the tests passing and the mainnet block numbers.
Cool. Okay, thank you.
Perfect. Parody.
For party, we merged the block number to master, but we haven't made a release yet. Expecting around the beginning of next week.
Okay. The beginning of next week. We can do a blog then, and that still gives us 3 weeks, roughly, a little less maybe. Um, and then we have. Oh, that might be everybody. Who am I missing as far as a client or important? Oh, sorry, Besu.
136, we have Robston and Mainnet, and we also passed the reference tests.
Okay, perfect. Um, am I missing anybody else?
Did anyone have a confirmation for Aleth?
Paul doesn't have his microphone working, so we'll just have to look that up.
Hey, so we haven't done anything yet, but hopefully we'll do it like at the beginning of the next week.
Okay, thanks for the update.
Cool.
Perfect. Cat herders, are there anything else that I'm missing as far as speaking to Mere Glacier? This could be Pooja or Tim.
I just have one question. Like in the beginning of this call today, we discussed that it can be occurring earlier. So in our post, we are trying to suggest that it is coming around this January 6th. Do we need to amend it? Like in the Istanbul testnet, when it appeared a couple of days before, we saw kind of panic. So can we change the date so that people should be prepared earlier?
Well, honestly, I would suggest that before New Year's Eve, everybody should really update. So currently, if the block numbers were consistent with the current speed, then it would actually land on New Year's Eve.
And Etherscan is showing the 30th now. I'm not sure how they do their calculations, but yeah, so it's like New Year's Eve or before, so we should, yeah.
Yeah, so can we put a tentative date as like 30th of December?
Oh, go ahead, Peter.
It's kind of hard to say because the difficulty just got bumped 600 blocks ago. So I don't know, that's quarter of an hour, half an hour ago, which kind of means that probably all the estimates are a bit off now. So let's wait until 2 more days and see whether the numbers change the estimates that Etherscan and Ethernode suggest.
So does it make sense then, yeah, to release the blog post on Monday? Hopefully Parity can have a release by Monday. And like we can release at end of the day America's time. So that means that, you know, Parity, I think you're all in Europe, so it's kind of well past the end of the day. And we can use whatever numbers are on Etherscan Monday, and that should give it a couple days to like readjust its estimation, given that the difficulty change just kicked in. Does that make sense?
That would be something we could do. What my suggestion would be to just say in big bold letters, have this done before the end of the year, but that say the estimation is currently plus minus 5 days between January 6th or on January 6th, plus minus 5 days.
But I think that doesn't really work for the worst case scenario. Like the worst case scenario is like the 30th or the 31st. I would almost be more comfortable saying do this before Christmas in a way. Yeah.
Okay. Yeah. Well, let's reassess on Monday, I'd say,
Sounds good.
and just see if it's changed.
Sounds good.
Awesome. Yeah, we can definitely talk more then. And if it needs to be on Tuesday because of other clients releasing, that'd be fine. We don't even have Trinity on the call or Ethereum JS, so I can reach out to them manually. Or we can just hit up their Getter channels. I think we're nearly done here. Let me go back to the agenda if I can find it. I have 30 tabs open right now, don't I? Where'd it go? Alright guys, almost there. I've been going through all my tabs. Well, I'm just going to go back to it again. Anyways, we have one more EFI, and basically that EFI is not truly a new EIP that we're discussing. It's kind of just a formality that we need to all agree on for putting EIP 1057, programmatic proof of work, into EFI, because it was already accepted in other all core devs decisions back to basically a year ago multiple times. So is anyone opposed to adding ProgPow to the list of EFIs? Granted that before any of this process was discussed, we made a decision on it. It kind of seemed like at least to James and I, it seemed like a something that we would need to do just for procedural reasons. So if anyone does have a comment on that, feel free to talk to the getter or bring it up here. The EIPIP, the EIP Improvement Proposal meeting, I've dropped the ball on that a few times. We haven't had it yet, and then I kind of started thinking about it, and everyone's slowing down because of the holidays, so it might be better just to push it till January, unless there's a different opinion on the call. And until then, I can make a telegram and start, getting people in that to have ideas and suggestions from those who've expressed they wanted to be involved in it. Because I think, yeah, at least Wei and I think Dano reached out, and I know Pooja's going to be a leader in that one, and a few other people want to be involved. So I'll make a telegram for that, and then probably the next core dev meeting, just ask again who wants to be in it, and I can add more people along the way. And then in January, we'll address it in a formal meeting after we've collected some ideas in the telegram. Any comments? Okay. Review previous decisions and action items from call 76. The last one, let's see here. Oh, does it have? Oh, I'm on the wrong thing. Sorry. 76 is done. I merged it today because there was a few corrections that needed to be made. So if you go to pm/all core dev meeting /meeting76.md, it's going to have the decisions. So EIP 2348 was listed as accepted and final. That is the validated EVM contracts. Let me go to it to make sure we're all on the same page.
I haven't done any updates on validated EVM contracts. I was going to wait until the new year to have another round of discussions on ACD.
Okay. I wonder why we have it as final. Is that a
I think it's a
mistake?
typo and it's 2384, and that's probably the Ice
Oh,
Age EIP. I'm not sure, but just like, yeah, looking at it, because 2387 is the Muir Glacier hard fork EIP, and so 2384 was the actual change in the upgrade.
got it. Can someone let Brett know to change that?
Yeah, I'll take care of that.
Okay, thanks, Pooja. Also, the EIP 2387 is put to last call. That one, oh, that one is the hard fork meta for Muir Glacier. The other one, if it's so 87 is the meta, and 84 is the difficulty bomb delay EIP
Yeah,
itself.
this one
Okay,
is weird because there's just one EAP in the meta.
got it. Okay, so this just basically covers Muir Glacier. Okay, if that was the decisions made, that's fine.
But both of theirs last call was supposed to end yesterday.
Yes.
Because we said initially just to take the standard 2 weeks. But since a couple of comments came up, as Peter mentioned earlier on the call, maybe it should be extended because it cannot be considered final yet. Or, well, I'm not sure, what's the status of them really.
Honestly, I'd say that they are both Muir Glacier ones are final at this point because we addressed the concerns that were brought up in the comments by saying that we are going to, in one way or another, address the overall idea of the difficulty bomb or after after Muir Glacier comes out. So I think that's sufficient. But if anyone has a dissenting opinion, speak up.
Well, the thing is that at this point in time, nobody will start debating and specking out and releasing new clients for a brand new changed hard fork. So we're going to go with it either way.
Yeah, that is kind of the reality of it.
So I think there was one comment on the wording of the EIP itself regarding 2384. And the comment said that the EIP refers to, I suppose, the previous. Yeah, I can't find it, but anyway, it says that the EIP refers to the previous difficulty bomb delay EIP, and just explains the difference, which is the block number. But the person who raised the issue said that the other one actually deals with reduction of the block rewards. And this EIP should also mention that the block rewards are unchanged. But there was only just a technicality on the wording of the EIP.
Okay. If that needs to be addressed, who thinks that needs to be addressed? Is that because like the last difficulty bomb adjustment did deal with an issuance reduction, I believe, but since this one doesn't, why does it need to be included? Did they explain that in the comment?
I think
they
it's the
just
two
wanted
last
clarity.
ones. Yeah, the two last ones had a reduction. I agree. It might make sense to have like that one line change to say specifically this one doesn't. I think the meta EAP might capture some of that. I know James had like added a section about like the rationale of like why we're doing this upgrade and about the difficulty bomb.
Mm-hmm.
Yeah.
Okay. Yeah, I mean, it won't hurt to put that in there. So I would say that, um, yeah, let's just ask Eric to add that line in there and hold it on last call until, um, and push it to or I should say, push it to final once that line is added. Does that sound good? I hear no dissent. That's cool. Um, is that it? That's it. For right now, let's say the next call's in 2 weeks, and because we can have just a really short call if we need to, and if there's not much on the agenda, I can almost put it as like a semi-optional call on the getter. Um, so we'll make note in the agenda itself that this will be a light call and that people shouldn't expect a lot to get done. So if you are coming to talk about an EFI EIP, you might want to wait till the new year. So yeah, call in 2 weeks. Anyone else have any further stuff to talk about? All right, everybody have a great holiday, and we'll see you in 2 weeks. Bye.
Bye.
Thanks,
Bye bye
Hudson.
all.
Thanks, Hudson. Bye.
Bye.
Bye-bye.
Thank you.
Bye. Thanks, everyone.